Today, for our review, let's look over what we did. The first one asked us to describe the end behaviors using your leading coefficient test. Our highest exponent is odd, and our leading coefficient is negative. So it will go up on the left and down on the right. So somehow up on the left to end, down on the right to end. For this next one, we have a function that we're going to find all the real zeros of. Now, first time through, if you want, you can factor it. You can factor out a 0 if you want to. Or you can look in your calculator and pull off any 2. You have 5 zeros. You have to get down to a quadratic. You can factor out an x and start with that. So there's your 0 if you want to. So we can see right away that x of 0 is a 0. Through your calculator, you can find 2 and 1 also. You have to get down till you have x squared. So let's take out your leading coefficients and watch the ones that don't have a coefficient. And let's factor out a 2. 2 is one of your zeros. So we bring it down, we multiply, we bring it down, we multiply, bring it down, and we multiply. This last one has to come out as 0. So now we're in x cubed, 3, 2, 1, 0. So now let's take out of that one more known root, and I'm going to use 1. Let's take out that root. We multiply diagonally, and we add down. And again, that should come out as 0. Now we're left with x squared plus 3x plus 2, and we can factor this into x plus 2, x plus 1. So you have all your zeros. You have x is 0, x is 2, x is 1, and then from down here, we have x is negative 2, x is negative 1. Don't forget your y-intercept. Your y-intercept says let x equal 0, and all of them come out, making this a y equals 0. Then we run it through your calculator, and we sketch. And we get a graph that looks somewhat like this. We can see that our domain is all real numbers, and your range is all real numbers. You can find your relative max at A, your relative max at C, your relative min at B, your relative min at D. Find those in your calculator. So A for a relative max would be negative 1.644. Make sure you go out 3 decimal places, 3.631. For C, your relative max would be 0.544 and 1.419. Your mins at B would be negative 0.544 and negative 1.419. And at D would be 1.644. And your y would be negative 3.361. Now, to do your increasing and decreasing, it goes off of those values. So you will be increasing from negative infinity to the top of A, negative 1.644. Remember to use only your x values. And you will be increasing again from negative 0.544 to 0.544. And lastly, from 1.644 to infinity. You will be decreasing for those in between. You will be decreasing for negative 1.644 to negative 0.544. Remember only your x values. And 0.544 to 1.644. Now, your inflection points. You had 5 zeros, 4 turns, 3 inflection points. Your inflection points are where you concave down and then you concave up. They have to share that. You equally share things. That's the midpoint. So you take your average of your x's. So to find point E, we're going to say negative 1.644, the top at A, plus B, which is negative 0.544, and we're going to divide it by 2. This gives us your x value. So this would be an x value of negative 1.094. Then you put it in your calculator to find your y at 0.604. The only time we need the y is just to name a point. This is inflection point E. Now, again, you're concave up, but then you're concaving down. So there is another inflection point. Let's call this F. So at F, we do the same thing. We add your x values from B and from C, divided in half. Your x was 0, and your y is a corresponding 0. And the last one, you're concaving up and down at the same time. So let's call this G. To find G, you're adding your x values only. So this x is going to be 1.094 and corresponding 6.604. There's your y value. Now, to find your concavity, you're using your x values to your inflection points. So first you're going to concave down. From negative infinity to that x value of that inflection point, negative 1.094. Then you're going to concave up from negative 1.904 to 0. Then you're going to turn again and you're going to concave down from 0 to 1.094. And you're going to turn again and concave up from 1.904 to infinity. And that gives us all of our parts for this one. In number 3, we're just going to do a synthetic division. So we pull out your coefficients, and remember to use a 0 for a placeholder. We don't have an x cubed. And count down, 4, 3, 2, 1, 0. And we divide by the 0, 3. Bring it down, diagonally multiply. Bring it down. Diagonally multiply, add down. Diagonally multiply, add down. And diagonally multiply one more time, and then add down. Since you divided an x fourth by an x, this is x cubed. 3x cubed plus 9x squared plus 20x plus 62, and here's your remainder, plus 176 over x minus 3. Now when we do your next one, be careful, because 2x minus 1, your divisor, x squared minus 2x minus plus 2x, has 3 terms. This leading coefficient is 1, so you're going to use these last 2 terms. So you're going to pull out the opposite way, a negative 2 and a 1. And you're going to pull out your coefficients. 1, watch your placeholders, and negative 11. So we've got 3, 2, 1, 0. You're going to do a double multiply. Multiply first by the negative 2, go to the right. Then by the 1, go to the right. Stop and add down your left column. Multiply again. Negative 2 times negative 2, 4. Negative 1 times negative 2, negative 2. Stop and add down. This last one right here, these last two are your remainders. You've got an x minus 2 plus 5x minus 13 over x squared plus 2x minus 1. On those, just stop there. These are no zeros, no roots. They're just plain divides. To find your zeros for number 5, you have 3 zeros. You can work with a quadratic, so you need to find at least one in your calculator. So I'm going to use the 0 of negative 3. Now, pull out your coefficients again. Hold those 0 spots. Bring it down and diagonally multiply. Bring it down and multiply. Add it down and multiply. This now has to come out to be a 0. Our factor theorem says if that remainder is a 0, then this in fact was a 0, and we knew that because we took it out. So since we were x cubed and we found one 0 of negative 3, we are now x squared minus 3x minus 10. And if it's factorable, you factor. And now you have your remaining 2 roots. So altogether we have 3 zeros. Negative 3, 5, and negative 2. Now this next one has a leading coefficient, has a leading exponent of 4, which means I have 4 roots. And I'm only looking for my real roots. If you graph it, you will see that it only crosses the x-axis twice, which means we only have 2 real and 2 are imaginary. So we look in our calculators and we pull out a negative 3 and a 3. So let's divide by the negative 3 first. Grab out all your coefficients. Watch if you need any placeholders. And then check. 4, 3, 2, 1, 0. Pull out a negative 3. Bring it down and diagonally multiply. Then bring it down and diagonally multiply. Keep the pattern until this is a 0. Now we knew that 3 was also a root, so we're going to bring this down as well. And that should be 0. So we are x squared plus x plus 1. Now this is not factorable, so you're going to have to use your quadratic in this. And once you get to this point, and you find that underneath your radical is a negative, you can stop because these are imaginary. So your real zeros are just the 3 and the negative 3. In this last one, we are given 3 zeros, a 2, a 3 plus or minus radical 5. These are conjugate pairs. We want to get back to the polynomial that has these roots. So we use this to find the factors. So we can start here with f of x equals x minus 2. That's one factor. Now when you work with your conjugates, remember you have 2 formulas. The sum of the roots and the product of the roots. So take the sum, 3 plus radical 5, 3 minus radical 5, this gives you 6. 6 is equal to negative b over a. We let a equal 1, therefore b is equal to negative 6. When you multiply the product, you multiply the first terms by the last terms, you get the product. You can even put that in your calculator. Therefore, c is 4. So now, you've got your second one, x squared minus 6x plus 4. And you can leave it in factored form. If we distribute that all out, that becomes to look like 5 or 6, number 5 and 6, where we actually went with your polynomial and found your zeros. So this kind of backtracks us into finding the polynomial.